you dear students, this is Sindhu Kaushik. So in the previous video I explained what do you mean by a function and some standard functions like constant function, identity function, modulus function, signum function, greatest integer functions and their respective graphs, and also a range, domain, codomain of those functions. So here is the class about types of functions. So the main types of functions are first one, OneOne function, OneOne function. Second one, OneTwo function. Third one, bijective function. So OneOne function is also called by the name injective function. OneTwo function is called by the name, another name for OneTwo function is surjective. So bijective function, that is OneOne and OneTwo. OneOne and OneTwo function. Bijective functions, another name is OneOne and OneTwo function. So first start with the definition of OneOne function. So first, OneOne function. OneOne function is a function or a mapping f from x to y. Here x and y are two non-empty set. So OneOne function is a mapping f from x to y. The mapping is said to be OneOne. So the condition is if f of x1 is equal to f of x2 implies x1 is equal to x2. That is, if images of the element x1 and image of the element x2, if images are equal, then the corresponding elements, here is the corresponding elements, are also equal. So this is the definition of OneOne function. Okay. So or you can say if the elements are distinct, it means they are not equal. This implies whose images are also distinct. That is f of x1 is not equal to f of x2. Then we say that the function f, the mapping f, is a OneOne function. A function f from x to y is said to be OneOne. The condition is if images are equal, then their corresponding elements are also equal. That is, if I take f of x is equal to f of y, if I take this one, if I get x is equal to y, their corresponding elements, that is x and y, if they are equal, then the function f becomes OneOne. Okay. So or if the elements x not equal to y, if the condition is if x not equal to y, if we get f of x, that is image of x, also not equal to image of the element y, that is f of y, then we say that that function is OneOne function. Okay. So this is the definition of OneOne function. Next, the other name for OneTwo function is what? Surjective. So the definition is a function f from a non-empty set x to a non-empty set y is said to be OneTwo. The condition is if for every element of the set y, if every element of the set y has corresponding pre-image, pre-image in the set X. So that is, for every element of codomain has corresponding pre-image in the domain. So in the notation, for all the element, say small letter y belongs to the set Y, that is the codomain, there exist, this is a symbol for there exist, an element say X belongs to the domain, say capital X, such that f of X is equal to Y. It means the image of X is Y. A function f from X to Y is said to be onto or surjective if for every element of the Y codomain has corresponding pre-image in the set, say X, that is domain. For every element of codomain, there exists a corresponding pre-image in the set domain. That is, if I take an arrow diagram, say X and Y, the mapping is F, 1, 2, 3, 4. Here I am taking A, B, C, D. So that is for every element of Y. Here for every element means A, B, C, D of Y has corresponding pre-image in the set X. That is, A as say pre-image 1. B has say, if I take 3, then the pre-image of B is what? 3. If I take for C 2, the pre-image of C is 2. If I take D, for D 4, the pre-image of D is 4. So for every element of codomain has corresponding pre-image in the domain, then we say that that function is onto. So this is a notation. For all Y belongs to Y, there exists X belongs to X such that f of X is equal to Y. Is it clear? So this is the definition of onto function or surjective. So next definition is what? Bijective function. So here bijective. A function f from X to Y. A function f from X to Y is said to be bijective. Said to be bijective or bijective function. The condition is if that function f is both OneOne and onto. So this is the definition for bijective function. If a function f which is both OneOne and onto, then we say that that function is bijective function, or other name is OneOne and onto function. OneOne and onto function. What do you mean by OneOne and onto function? The word itself says OneOne and onto. That is a function which is both OneOne and onto. Then we say that that function is OneOne and onto function. Is it clear? So this is the definition for OneOne, onto and bijective. If I consider like this, 1, 2, 3, 4, say here A, E, I, O, U. If 1 maps to A, 2 maps to A, 3 maps to A, 4 maps to A, it means what? Image of 1 is A, image of 2 is A, image of 3 is A, image of 4 is A. That is, f of 1 is equal to f of 2 is equal to f of 3 is equal to f of 4, which is equal to what? F of 1 equal to A, f of 2 equal to A, the image of 3 is also A, image of 4 is also A. That is A. It means all elements maps to single element. That is, many elements maps to only one element. That is many one. Is it clear? So which is an example to explain many one. What do you mean by one? In one, images are not equal. It implies the elements, corresponding elements are not equal. Here images are equal, but the elements 1 and 2. Here 1 is not equal to 2, but images are equal. So this is a reverse of one. So therefore this is the definition for many one. Okay. So here I am taking all together. So that is OneOne, OneTwo and bijective. Here I am taking OneOne, OneTwo and bijective. Okay. So what is another name of OneOne function? Another name for OneOne is injective. For OneTwo is surjective. For bijective means OneOne and OneTwo function. OneOne and OneTwo function. Okay. So what is the definition of OneOne function? If images are equal, this implies the corresponding elements are also equal. Okay. Or if the elements are distinct, this implies the corresponding images f of x1 not equal to f of x2. That is, image of x1 not equal to image of x2. If the elements are distinct, then whose images are also distinct, then we say that that function f is OneOne. For OneTwo, what is the definition for OneTwo? For every element in the codomain, in the codomain, there exists corresponding pre-image in the domain. We obtain images in the codomain, but pre-images in the domain. So this is a definition for OneTwo. That is, for every element in the codomain, that is for all elements, say y, where in the codomain. In the codomain means the capital Y. If I take a mapping f from x to y, codomain is y. Okay. For every element in the codomain, there exists corresponding pre-image in the domain, say x. In the domain is what? Here x. So x belongs to x. Such that f of x is equal to y. That is, image of x is y. Pre-image of y is x. Is it clear? So this is the definition for surjective. Next, for bijective, what is the definition? If f is the function f from x to y is said to be bijective if f is both OneOne and OneTwo. That is, if f is both injective and surjective, then we say that that function is bijective. Here bi means two. Two condition is there. That is, one is injective, other one is what? Surjective. Then it becomes bijective. Is it okay? Here I am taking 4 arrow diagrams or 4 functions, namely f1, f2, f3 and f4. That is by means of arrow diagram. Let us check whether f1, f2, f3, f4 are OneOne, OneTwo or bijective. So let's start with the function f1. So to be OneOne, what is the definition? To be OneOne, images are equal implies what? The corresponding elements are also equal. Okay. Or if elements are distinct, then the corresponding images are also distinct. That is OneOne. What is OneTwo? Next, for OneTwo. So what is the definition? For all y belongs to the codomain. For every element in the codomain, every element, there exists corresponding pre-image in the domain such that f of x is equal to y. So for every element in the codomain, there exists corresponding pre-image in the domain, that is onto. Okay. So first check for the function f1. So here 1 maps to a, that is a is f of 1. 1 maps to a means image of 1 is a. Here 2 maps to b means image of 2 is b. Now here 3 maps to d means what is d here? F of 3. Next, what about 4? 4 maps to c, that is f of 4. Image of 4 is c. Here a is image of 1, b is image of 2 and c is what? Image of 4 and d is image of 3, that is d is equal to f of 3. Is it okay? So now let us check for 1, 1. For 1 not equal to 2, what is f of 1 and f of 2? Here 1 is not equal to 2. Elements are not equal. What about their images? F of 1 and f of 2. Here f of 1 is what? A. And f of 2 is what? B. So therefore they are not equal. So for 1, 2, is it over? It is clearly over. Next for 2, 3. What about 2, 3? For 2, 2 is not equal to 3. What is f of 2 and what is f of 3? F of 2 is what? B. And what is f of 3 is D. Clearly B not equal to D. Okay. So for distinct elements we have distinct images. Distinct images. So distinct elements have distinct images. If I take 3 and 4, for 3 and 4 also 3 not equal to 4 and D not equal to C. So therefore distinct elements have distinct images. Therefore, it is clearly 1, 1. Is it okay? So, let us check for onto. Now, let us check for onto. For the function 1. So, it is clearly 1, 1. Next, what about onto? What is the definition for onto? For all y belongs to, for every element of y there exists x belongs to x such that f of x is equal to y. It means take any element of the set y, that is the codomain. There exists an element in the codomain. For E, is it a pre-image for the element E? No. If I take F, is F maps to any element or is F have the pre-image in the domain? So no. Here E and F both do not have pre-images in the domain. Therefore this given function F1 not onto. Reason is to be onto every, for all y belongs to y. There exists x belongs to x such that f of x is equal to y. Here for every, here E and F are elements of y. But E and F don't have any pre-image in the set x. So that is E does not maps to any element, therefore which is not onto. So F1 is clearly 1, 1 but not onto. So what about bijective? Here to be bijective, what is the definition? It is both 1, 1 and onto. Here this function is 1, 1 but not onto, therefore which is not bijective also. Next. For second function, here I am taking F2, 1 maps to B, 2 maps to B, 3 maps to C, 4 maps to D. That is, image of 1 is B. Here B is what? F of 1. And also 2 maps to B means what? B is also equal to F of 2. Is it okay? And 3 maps to C, it means C is equal to F of 3. D, 4 maps to D means what? F of 4. Is it okay? So let us check for 1, 1. Here 1 not equal to 2. The elements 1 and 2 are distinct. What about their images? F of 1, image of 1 and image of 2. F of 1 is what? F of 1 is say B. What about F of 2? 2 also maps to the same element say B. F of 2 is also B. Here they are equal. B is equal to B. Is it clear? So F of 1 is clearly equal to F of 2. But their elements are not equal. Here elements are distinct but images are unique. Therefore, which is not a 1, 1. To be 1, 1, what is the condition? if the elements are distinct, whose images must distinct. If the elements are distinct, whose images must be distinct. Okay. So here F2 is not 1, 1. What about OneTwo? To check for OneTwo, what is the condition? Take any element of the codomain. That element must have the pre-image in the domain. Here I am taking E, which is an element of the codomain, but which do not have any pre-image in the domain. So therefore, if I take F also, here F also don't have any pre-image in the domain. But these two are elements of codomain, but do not have a pre-image in the domain. Therefore, which is not OneTwo. So which is clearly the function F2, which is not OneOne and not OneTwo. Therefore, which is not bijective. Next, let us check for F3. Here, F3, 1 maps to A, 2 maps to A. Here, 1 is not equal to 2, but mapping goes to the same element. Means F of 1 is equal to F of 2. What is that? F of 1 is A. F of 2 is also A. A is equal to A. Clearly, A is equal to A. So here, 1 is not equal to 2. That is, elements are distinct, but images are same. Therefore, which is F3 is not 1, 1. So why it is not 1, 1? Because here elements are distinct, but images are same. Okay. So next, what about OneTwo-ness? Here, A has the pre-image, namely 2 and 1. B also have the pre-image, say 3. C also have the pre-image, say 4. Every element of the codomain has a corresponding pre-images in the domain. Therefore, it is OneTwo. Therefore, it is OneTwo. So, which is not 1, 1, but it is OneTwo. In fact, which is not 1, 1 means what? This is many 1. Why it is many 1? The elements, many maps to only single element. That is, if I have the symbol, like, if I have this symbol, then you write, this is many 1. Here we have the symbol like this. That is many 1. Many maps to single element. That is many 1, not 1, 1. So, next, F4. Here I am considering 1 maps to B. That is, B is F of 1. Next, 2 maps to C means image of 2 is C. 3 maps to A means A is image of 3. Next, 4 maps to D. So that is image of 4. Here, 1 is not equal to 2. 1 not equal to 2. What about their images? F of 1 and F of 2. Is they are equal or not? F of 1 is B. F of 2 is C. Therefore, they are not equal. Distinct elements have distinct images. If I take 2 and 3, 2 and 3 also, for 2, F of 2 is C. For 3, F of 3 is A. Therefore, they are distinct. If I take any number which have distinct elements, have distinct images, therefore, it is clearly 1, 1. What about OneTwo? For A, it clearly have pre-image, say 3. For B, it clearly has pre-image, say 1. For C, it clearly has pre-image, say 2. For D, it clearly, the D element of the codomain has pre-image, namely 4 in the domain. Therefore, every element of codomain has a pre-image in the domain. Therefore, which is OneTwo also. So, this is 1, 1. F4 is 1, 1 and OneTwo. Therefore, it is an example for bijective. Is it okay? So, F1 which is what? Which is 1, 1 but not OneTwo. Here this is not 1, 1, not OneTwo. Here which is also not 1, 1 but OneTwo. Here this one is 1, 1 and OneTwo. Is it okay? Here is the graphical method to check whether the given function is 1, 1. In the previous video, I explained graphical method to check whether the given curve or relation is a function or not. So, where I am using vertical line test. Here, the graphical method is horizontal line test. Horizontal line test. to check the given function is whether 1, 1 or not. So what the horizontal line test says, if I have a graph, say like this, if I have a graph like this, draw a horizontal line that is parallel to x-axis. If that line touches a curve at only one point, then that curve or that function is what? Then that function becomes 1, 1. If I draw a horizontal line to the curve, if that line touches a curve at only one point, then that function or curve becomes 1, 1. Next, if I take another graph, say V-shaped graph, what that represent? V-shaped graph is what? This is a modulus function graph. In the previous video, I explained the graph of modulus function where I get V-shaped graph. Is it okay? So if I draw a horizontal line, then what? If I draw a horizontal line to this function, to this modulus function, that line touches that modulus function at 2 points. Okay? At 2 points, namely this point and this one. So therefore, which is not 1, 1. To be 1, 1, that horizontal line must touch the function or curve at a single point. Then we say that is 1, 1. Here, this function which is not 1, 1. Okay. So why it is not 1, 1? If I am taking the modulus function f of x is equal to mod x, f is a mapping from set of all real numbers to set of all real numbers. That is, if I take arrow diagram 1, 2, minus 2 and 4 and say minus 4. If I take these numbers 1, say 2, say minus 2 and 4, say minus 4. I am taking the same numbers in the codomain also. Here, what is the f of 1? F of 1 is modulus of 1. Modulus of 1 is what? 1. So 1 maps to 1. Is it okay? If I take 2 in place of x, that is f of 2. F of 2 is what? Modulus of 2. Modulus of 2 is 2. So that is 2 maps to 2. If I take in place of x has minus 2, what is that? F of minus 2 is mod minus 2. So modulus of minus 2 is plus 2. Why it is? Go back to the previous video. Watch that video. You will understand what is the modulus of minus 2 is. Why the modulus of minus 2 is 2. Okay. So modulus of minus 2 is 2. Here modulus of minus 2 maps to 2. Is it okay? 4. Modulus of 4 is 4 maps to 4. Modulus of minus 4 is what? Plus 4. So therefore which maps to 4. Okay. So here let us check for, here we have this shape. Means what? This is not 1, 1. If I have this structure like this, then it becomes what? Many one function, not 1, 1 function. So here 2 is not equal to minus 2. That is, the elements are distinct. What about f of 2? F of 2 is 2. What about f of minus 2? Both are equal. In fact, f of 2 is 2. F of minus 2 is also 2. So the elements are not equal, but the corresponding images are equal. Therefore, the definition itself says the function which is not 1, 1. Is it okay? So horizontal line test also says which is not 1, 1. By arrow diagram we can get, or by definition we get which is not a 1, 1 function. Which function? Modulus function which is not a 1, 1 function. Is it okay? So this is a horizontal line test to check whether the given function is 1, 1 or not. Is it okay? So next